Following, we will hear from Kim Diederichsen, CEO of Anemoi Marine Technologies, on innovations in ship design for enhanced energy efficiency, the case of wind propulsion. Let's welcome Kim.
Perfect. Welcome everyone, and thank you to the organizers for letting me introduce you to the topic of wind propulsion, to Anemoi, a London headquartered company specialized in designing, building and bringing rotor sails to the market. I'm sure many of you have seen, have heard, you may have even a life experience with wind propulsion as of today, but just making sure that we all understand what wind propulsion does to the ship when it's rolled out, and the reason why it's currently being rolled out significantly. As I would say, we have reached the inflection point where the uptake is really happening. So just making sure that we all are aware and what it's about. Rotor sails are basically spinning cylinders. And when a spinning cylinder is placed in an airflow, the air speed in front of the rotor is accelerated, therefore creating a pressure differential over the rotor, which will have an impact of thrust to be created for the ship, consequently propel the ship forward. So no electricity generated, it's pure thrust that is generated, and it's called the Magnus effect. This is how it works. It works on, has been around for 100 years. So this is something that is proven for sure. Today, we have a wide product range spanning from very large rotors, and the ones that you see on the right, they are actually 35-meter tall and 5 meters in diameter, very well suited for very large vessels, and spanning all the way down to the 3.5 meter in diameter and 21 meter in height. So different type of rotor sails needed for different type of vessels. And the reason why we have such portfolio is also to maximize the thrust that can be installed on a ship at any given time. So this is the rollout. If I should give just as of today, a status of today, I would say the 5x35s for the big ships, typically an MR tanker, so a 50,000 deadweight tonner upwards, and also for Kamsarmaxes, so 80,000 deadweight ton in the bulker segment upwards, will fit the larger rotors that we're seeing out here. See, the rotor sails have been around with other wind technologies for some years, but that's really, or that was at least, not really the problem why we didn't see the uptake. Fuel costs were low, there were no initiatives to do so, and there were a lot of challenges of actually installing wind propulsion. What we are seeing today is that what we've developed is at least 4 different ways of installing the rotor sails. So, and we name them the deployment systems. We can have them fixed installed, we can fold them, we can rail them longitudinal, and we can also rail them in the transverse direction. And looking at the rail deployment and the folding applications here, the deployment system, I would think, or to say today, this is one of the reasons, because we've overcome these challenges of actually doing it. That's one of the reasons why we're rolling it out. And what you're seeing here is an example of rotor sails. A vessel has here come alongside, cargo operations is ongoing. The loaders, if the rotor sails were in its normal position when sailing, here in this example at centerline, they would have been in the way, consequently in the way of the loaders. So here we rail them out to port side, and the loaders here can freely operate. Another example here is one with a longitudinal rail. This vessel is a geared vessel, so even more challenging. And when alongside here, we can see that the rotor sails can simply be railed up and down the side of the deck, positioned and far away, and thereby not disturbing any cargo operations. The last one that we see on the large bulker segment and large tank segment are also requests on these ships to have a folding type of rotor sails. And the reason why we do that is all driven, again, mainly due to cargo operations, but also for maneuvering, going under bridges, etc. And it's a myth to believe that rotor sails in harsh environment, in very bad weather, will have to be folded down. This is not the case. The only reason why you would fold them down is because of in-water, shallow water maneuverability of the ship, and due to cargo operations, so the loaders can pass over the rotors. These rotors, they are extremely and very well suitable for harsh environment. In fact, we can see operations all the way up to 35 meters per second for the rotor sails, where we can benefit from the wind. And even in extreme hurricane condition, the survival condition of a rotor sail is 65 meters per second. So I would not recommend for the ship to be in such conditions. I would think that's a problem for the captain. Today, I have got in London more than 70 great colleagues with an engineering office down in Brockenhurst, but we've moved all physical production away from the UK. We have a massive, very large production setup in China, more than 250 people working in our supply chain, in our own team, building these rotor sails. So I like to say it's a whole forest of rotor sails that we're seeing here, and we're scaling up. And the reason why we're doing so is because there's a demand. There's a strong demand for wind propulsion in today's market. Another reason why we moved the whole, during the pandemic here in 2020, 2021, the whole supply of the rotor sails to China was to come closer to our core market, where the ships are being built, where the ships are being serviced, and where the ships are docking and on typical trade routes. We wanted to come closer to our clients. So this is what you're seeing here today. Capacity, we can produce roughly 50 of the large rotor sails on a yearly basis and half of the smaller size. So production capacity around the 75 rotor sails per year, only increasing as we go ahead. And we have a fully implemented strategy plan of coming up in a period of time up to a capacity of 250 produced rotor sails per year. Let's have a look, maybe take a look at some case studies, but also finding out the reason why wind propulsion, and in our case, rotor sails, are now being adopted in the industry. I'll give you two examples and maybe answer the question why this is happening as we speak. This case here, it's an MR tanker, so a product carrier, 50,000 deadweight ton, illustrated with the implementation of two 5x35, assuming the ship will trade globally here 250 days a year. The numbers would then look like this, assuming, looking 5 years back in time at the mid-ocean condition, crushing us through our mathematic models, etc., both in laden and in ballast, all over time, across here. If the ship was trading globally, all over the world, approximately 20% saving in fuel and emission savings will be achieved. On specific typical MR routes, these are the numbers that you're seeing. So a significant impact on fuel and emission reductions. This is definitely one of the reasons why the uptake is happening as we speak. Another one is the impact on CII, talking about the drivers. Why are owners and managers and charters coming to us? Why are they asking about wind propulsion? I think you can clearly see the answer here. It simply prolongs and makes sure the vessel remains compliant in this example. Same with the taxation that is now kicking in. Fuel EU rewards that we're seeing and the ETS scheme. The business case of wind just becomes more and more attractive. So from having a standalone application, only the fuel savings, here monetarized, showing without fuel EU and the ETS schemes, you'll see there's a big difference. These are some of the drivers when owners and managers are building up the business case to assess, is it worth it of installing rotor sails? Another one could be a Kamsarmax vessel, here installed with the transverse rail system, a little bit smaller rotors, 5x24s. The numbers, a little bit less, still significant, I would say. But one could also install and optimize the savings by use of voyage optimization, weather routing, in addition to the wind propulsion. If combining these two technologies, savings will improve. Here, the route, as illustrated, a trip, a voyage from Australia going up north to China, 20 days at sea. It would look like this, something like this. With the vessel without any wind propulsion, the savings both in percentage and in absolute tonnages, here with rotors installed. And if you add to the equation the voyage optimization, weather routing, another typical 5, 6, 7% can be gained. All our projects that we're currently seeing, this is currently being implemented. So we're offering this package deal as well, where we combine it and making sure that the clients get the best benefit out of it. A couple of examples. Where are we right now? So we're rolling out. I'll show you, let's see if it works, a little video from the MV Afros, 6 years in operations now, a 64K geared bulker, a Kamsarmax vessel which was delivered a year and a half ago with 3 rotor sails, and a June delivery here, the Bergen Eblina, which was delivered in June. She's done her maiden voyages, etc. Let's see if the video plays. Sorry, it doesn't. So I'll have to have the voiceover here. So we did the full installation during the normal ship docking at the yard. Some of the projects, I would say, can either be delivered as wind ready or as a direct install when the ship anyway is coming to and doing the services, typically the 5 years or the intermediate services. The industry is young, and what we're seeing out there, there's a lot of uncertainty. There's a lot of still knowledge to be gained by the yards that are supporting the installation, the physical installation of the rotor sails. Consequently, we've also found that owners and managers, and here our clients in general, they are relying on us helping them, making sure that we have a smooth, easy, and as fast as possible integration and installation of the rotor sails. Consequently, what we're doing today, we have a whole range of additional services that we help them all the way from early stage, very, very close to a full turnkey installation of rotor sails. And I think it will only become better once we see many more wind systems, wind propulsion systems being installed in the market. And until then, I think there's a strong need making sure that we on the supply chain helps owners and yards making it as smooth as possible. What we're doing as well right now, quite interesting, I would say. These days, as we speak, though, right now, disturbed by the typhoon that's currently crossing over Shanghai, we are installing on the world's largest ship, the Sohamax, for Asiat and Vale, 5 big rotors on the VLOC currently being installed. And also, we are doing some projects here where actually dual wind propulsion is going to be installed on ships. Not only one wind propulsion, but dual. We have entered into a collaboration agreement with Japanese MOL, where the Wind Challenger, a rigid sail, will be installed on the bow of the ship, combined in combination with rotor sails on port side. So the dual wind propulsion is something that we're going to see on ships. And whether it's going to be the new norm, I don't know, but at least what we can say, savings and impact are enormous by such ships. So in conclusion, coming to an end, I think to say with from the International Wind Ship Association, an estimated 100 ships by end of this year, either ordered, in production, or delivered with wind technology installed. I do think the market has matured. We've reached the inflection point. We are coming out of the early stage piloting. We, on our end, are at least entering into fleet and fleet agreements and wider rollout. And the reasons are due to what you're seeing here. Has an impact on the environment. This is a super efficient technology that goes hand in hand with many other technologies, and it's currently being rolled out. That was it. Thanks a lot.